אז בוקר טוב לכולם, שמח שהצטרפתם ליומיים האלה של DevOpsDays, ספונסרים נמצאים על הלוח, שמי גדי נאור, אני ה-CTO ואחד מהפאונדרים, חברה בשם על Seed.io, והיום אני הולך בעצם לדבר על מה זה אומר ארכיטקטורות של Serverless, ומה זה אומר בעצם לעשות איזושהי אבסטרקציה לסביבות שלנו. אז מצד אחד אנחנו יודעים את כל היתרונות בלא לנהל שרתים ולא לנהל את החלק המכני של זה, אבל זה מביא איתו המון אתגרים שקשורים, החל מהפיתוח, עבור לטסטים, לתוך האופרציה וגם המון הדברים בסקיוריטי. בכמה מילים על עצמי, אני מתל אביב, מה שאני לא עושה כשאני עושה טכנולוגיה וקוד זה סקייטבורד, אני מקווה לעשות את זה עד שאני לא אוכל ללכת. בינתיים זה עובד בסדר, אתם רואים כבר שערות לבנות, אז זה לא קל לעמוד בקצב של הצעירים יותר. הרקע שלי הוא סקיוריטי, בעצם אני כל חיי מבלה בלבנות, בין אם זה VPN, firewall'ים, IPS'ים, וככל שאנחנו רואים את העולם הזה מדרדר במרכאות לקלאוד ולקלאוד נייטיב, החברות המוצרים שבניתי בעבר הם די הופכים להיות לא רלוונטיים בעולמות האלה, מה שהופך את זה למאוד מאתגר. היום אני בעצם חלק מחברה שמה שהיא בונה זה מערכות של Microservice Firewall, מערכות מתקדמות כאלה שיודעות גם לעשות את הסגמנטיישן, אנחנו קצת ניגע בזה באספקטים של Serverless, אבל גם זה אומר זיהוי אנומליות, שאני חושב שזה אחד הדברים המאוד מהותיים כשהם נכנסים לאופרציה שהיא בלי שרתים והיכולת שלנו לגעת בחלקים הנעים בצורה שהיא נקרא לזה איכותית. All right, so going back to these nice drawings of our day-to-day life with microservices. So essentially, when we move into microservices, we break down the entire monolith that we were part of, basically building for many years or months, depends on how old is the company that you work for, the project that you work for. But essentially, when you break it down, you employ multiple components that are necessarily distributed to support scale. Sometimes we are, let's say, digressing into spanning infrastructure over multiple regions, multiple availability zones for sure. But if you go multi-cloud or any advanced use cases like that, it becomes extremely complex to even control all the moving parts that you have at your hand. And it's not only the operational side of things, but also on the test side and on the operational, of course, but the application monitoring and security becomes an extremely complex. Just think about even the simple thing as firewalls. We used to have firewalls at the edge, and now once everything is running inside with one hop from the cloud to the outside world, firewalls are not the very effective way to kind of build a perimeter around the moving parts. And when you go serverless, when it comes to serverless, it really defines new perimeter. Oftentimes we are running our entire infrastructure fully hosted over the cloud provider. And there is a balance between whether we are in control versus are we managing infrastructure, which both of them has pros and cons. And in this talk, I'm going to kind of give you the check and balance between what does it mean to run fully hosted using serverless infrastructure, but on the other hand, I will show you some examples of how we do similar things with fully managed infrastructure that does give you serverless programming environment. When you think about the span of the problem that we're dealing with on our day-to-day development life cycles, and the infinite loop here really manifests the challenges the developer have by building the code, testing it, and then continuously deploying that into production, releasing that into production. It can be differential updates, just updating a single microservice or a single serverless. And at the end of the day, when you think about it, serverless is just an application vehicle. We can implement it using containers, we can implement it using bare metal or even VMs, but necessarily, these are all application vehicles for our code and our business functionality. Now, the challenge around each and every one of those steps is how do we make sure that we build the system from day one to be operational friendly and to be verified from a security standpoint, and the verification from the security standpoint can start with you scanning your code for vulnerabilities, you making sure that your software supply chain is coming from trusted sources, and we all heard about the recent Node.js commits of attackers into the repositories themselves. So out of the gate, you are actually potentially bringing in code that can contain something that is not of the original intent of the developer. So we are going to touch on those four kind of area, and with a focus on both the developer, the operation, and the security side. So, wow, this is all right. So when we think about serverless and serverless architecture, we can think about it from an operational standpoint, meaning no service, fully managed security. Think about Lambda as kind of the go-to use case for serverless, but RDS or any fully managed service that you are not actually managing the underlying infrastructure would fit into that model. But serverless can be just as much a programming model. What does it mean? It means that it's service-based. We're thinking about application as an aggregation of services that have strong API boundaries between the different services. And then those services are either triggered by user requests, by events, and the underlying infrastructure to drive this could be message queues, could be emails, could be text message or whatever. But at the end of the day, when you think about the programming model, this is something that is very powerful for the development team. Because essentially, we broke down the application into multiple microservices, and teams can move in parallel. So as long as they are keeping very strong isolation on what are the APIs, are we changing APIs responsibly, meaning that we do not modify semantics or syntax. But on the other hand, we do preserve backward compatibility between the different microservices and the API boundaries. So when we go into the serverless operational model, we think about what is it that challenges the most once we go into like fully managed infrastructure. And the first thing that you meet when it comes to serverless is testing. Testing under serverless infrastructure means that you need to build an abstraction between how your code is working on one hand, and how things or elements or events are triggering that code. So the abstraction is extremely complex. Think even about Lambda. Lambda is a time box machine. You have no control where it's running. You have some control on what is the duration of the Lambda runtime. And then when you think about how do you debug Lambda applications or serverless applications that are time boxed, how do you monitor those applications? What do you do if you have a security event on one of the Lambda invocations that in a minute from now, there is not really something that you can log into a server or even do that? I don't know if any of you opened a reverse shell into a Lambda. It's a pretty restricted environment. You cannot do a lot in terms of actually understanding what's happening on the inside. But on the other hand, think about kind of the go-to best practices that you do as a developers. Setting up a comfort zone of a debugging infrastructure is kind of the first thing that you do as a developer. So these challenges, once you go into Lambda, it pretty much shake the world that you know on a day-to-day basis. And the same challenges apply once you think about monitoring. And I will touch about that in the next few slides. So let's talk a little bit about the testing strategies and what are they. So if I'll take an example of an open source project recently presented at reInvent, the Soleil, if I pronounce it correctly, it means I'm sorry. Think about mobile application where you want to collect errors from the mobile application, and your Edge API, collector API, is basically a Lambda function that you ingest inbound different events, and those events are basically coming on SNS topics, and based on that, you propagate that into a persistent storage. You can propagate metrics, you can propagate it into an S3 bucket. So think about what would it take to actually build the testing environment or the function that implements the internal side where it routes the different logs and errors into the different persistent storage. So when you build this function, you essentially need to define a very strong boundaries of what's coming into the function. So you can actually mock it using a local triggering mechanism. So essentially what you can do at the end of the day is run that locally using Docker Lambda or any of the local testing tools for Lambda. And then anything that goes out of function into the persistent storage is something that you also want to build an abstraction for. So whether this is an S3 or whether this is a database, at the end of the day, you want to make sure that you can activate your function using those abstraction and understand what is happening inside the function from both the functionality perspective, meaning that you want to make sure that the happy path is really happy and everything is happening as expected. But going to the other side is how do you make sure that from a security standpoint, you can security test your code. You can try to manipulate the APIs using fuzzing, meaning that you try different input mechanisms, different inputs into the API boundaries, and making sure that the outcome is as expected. And the testing part is something that is really challenging from a developer standpoint because we need to develop out of the box very strong API boundaries and actually build a mock for each and one of the microservices that we deploy. So it is an overhead from a development standpoint, but on the other hand, these are very good development practices to define those boundaries and APIs. Not to mention that if you get to do the security testing early on with your development practices, then it really gives you a handle of what will happen in the production. So when we think about local testing, there are, I listed just two of the kind of tools that are out there for local testing. There are many tools. Some of them are coming from the cloud providers, and some of them are open source projects that are basically enable you to test locally what you are running. The next kind of, and let me skip to the original slide of microservices. Think about monitoring and tracing issues in production when it comes to distributed environment. It's not particular to serverless as in general. This is a general problem that is associated with distributed systems and microservices as an implementation of distributed system. Originally we had the monolith server, we had a two-tier application that was quite simple to understand. If something is busy looping on the API server, or it was busy looping on transaction to the database, or the queries to the database are inefficient, think about a transaction that need to traverse multiple microservices. It might go in, through Kafka message broker or SNS queuing. And at the end of the day, thinking about what is the user impact when it comes to tracing is something that is extremely complex to actually understand what is happening. Take that notion into serverless, you don't even have control where the code is running. So if you could log in to a server and understand what is going on from a troubleshooting perspective, or you could scale down your entire application into something that is running with a replica level of 1, then you could actually do some debugging and understand along the way what was breaking. So luckily enough, there is new framework or relatively new standard around tracing and monitoring, which basically called Open Tracing. It is sponsored by the CNCF, which is basically the umbrella project that Kubernetes and Istio and many well-adopted open source projects are basically employing. And at the end of the day, what it gives us the framework, the API definitions of how do we collect telemetry from microservices that span across multiple transactions by associating a specific ID. And I would like quickly ask, like, which one of you associate IDs with their debug trace logs to actually search them afterwards in production? it should be most of us that are doing that practice. Open tracing gives you exactly that. Essentially, it gives you to associate a transaction ID with HTTP requests, and over time, it will expand into additional protocols. And then you can trace the span, meaning that the entire microservice transactions across the different microservices, and give you essentially insights of what exactly is happening from an operational perspective, meaning how many time we spend in microservice A, B, or C. And let's see an example of how we do that. One thing to note, this is when we go into serverless applications, meaning that we are not doing anything like Istio or Service Mesh or any of those new frameworks. It does mean that you need to integrate client libraries into your runtime code that basically activates the different tracing mechanisms and emit those traces to a tracing aggregation service. And you can see that on the right-hand side, there are open source projects like Jagger and Zipkin that basically aggregates the different tracing data and can give you something that looks like that. It can track and give you how much time did we spend in each and every one of the services that is running east-west inside your environment. And from an operational perspective, when you think about what do you want to have the most from your systems, you want your system to tell you that something is off. You do that by searching for anomalies, any irregularities that are associated with an error trend that, let's say, for example, an API starts to return a 500 HTTP code or a 404 that presents a negative trend. These are the points where you want your system to actually tell you that something goes off, because at the end of the day, we cannot actively look for elements that are not working in the system. Tracing is just one aspect, meaning that if one of the services exhibits a degradation in the response time, in the average or the mean time or the P99 response time, this is where actually your SRE or the DevOps are kicking in and actually looking into the problems, whether this is something that is associated with the infrastructure. In serverless and Lambda, this is not something that we would expect from the infrastructure to actually show sluggishness and slowness. But when you think about actually serverless in the managed use case, which I will show you in the next few slides, then this is something that you actually want to see if there's something off with the servers, if there are enough resources, and so on and so forth. So let's talk about how do we operate serverless architecture in a fully managed environment. So anyone here heard about Knative? All right, so for those who doesn't know, it's a new project, open sourced by Google and sponsored by IBM and Red Hat and basically all the kind of vendors that support Kubernetes and Istio. Anyone here heard or worked with Istio? Okay, more folks. And Kubernetes? All right, better. So when we think about this cloud native trifecta, essentially this is basically the technology stack that drives us into running serverless infrastructure in a fully managed environment, meaning that Kubernetes delivering the primitives to deploy and orchestrate workloads. Istio is basically the control plane and the backbone of connecting services in a meaningful way and a reliable way, an observable way. And Knative is basically the PaaS abstractions or the platform as a service abstractions that give you the ability to run application, modify application, deploy application in a relatively easy way. Now, I will say that the disclaimer here that these are early stage projects. Now, I know that as a DevOps, we all love the experimental stuff. But once you go into production, this is something that you need to carefully examine when is the right time to engage. So Kubernetes, for that matter, is relatively mature enough. There are thousands of companies that are running that in production, including ourselves. And then when you think about Istio and Knative, these are more at their early stage, even though Istio is GA'd. there are still many elements to Istio that are missing. So quickly about the kind of new stack associated with Knative. It essentially brings in a lot of capabilities to both the developer and the ops side of the world by building and orchestrating code from Git, delivering that into production. And what I would like to walk you through is how do we do blue-green deployment under this platform. So I'll skip through a couple of slides here and kind of lay the foundation of what the Knative serving primitives are, in the sense that Knative defines a service as the configuration and the association of route with configuration. And kind of those two becomes your microservice. Now, anyone here does in practice blue-green deployments, meaning that you deploy 2 versions of your microservice and steer traffic, some percentage of the traffic to actually test. Is this something that anyone practically do today in production? Okay, so if anyone did that by hand, it's not an easy problem on a day-to-day basis to actually deploy different microservices manually or automatically and do the traffic steering at the edge. Knative out of the box bring that exact capability, and it looks very promising, at least from the early tests that we have conducted. But then again, there is a lot of component in that technology stack that can challenge each and every one of us. So when we think about what does it mean to do the blue-green deployment, so I took here an example of the configuration file in Knative. It looks very familiar to regular Kubernetes resources. And at the end of the day, you define here a snapshot of your code, a build of your code that basically represents the blue version of our code. You apply it into production by just doing the kubectl apply and the file name that contains that resource. And the system behind in the background create a revision that is revision 1 of this specific resource. If I will do that again with different version, it will automatically create a new revision. And this is exactly what we are going to do next once we are going to deploy our green version. In that specific deployment, we deploy a route that basically defines how the service mesh or the serverless platform routes traffic to my different code revisions. So essentially what it means that I can define a route, I can define what is the backing workload and the revision of that specific workload. And based on that, I also define that the revision, 100% of the traffic, I steer into the blue version. Once a new build is available, we do the exact same deployment of the resource file into the platform, into the stack, meaning that now the build now carries the green version that we want to deploy into the production. And the one thing that is left out of this operation is basically to steer the traffic into the next phase. And that is something that we basically articulate by changing the route. So right now, the route basically say that I have 2 revisions that are running in my deployment or my production workloads. And presently, the revision basically says that I still steer 100% of the traffic to my blue version. And all I need to do is just play with the steering of the percentage of the traffic in front of us. So now I can slowly shift 2%, and initially it makes sense to kind of try and shift 2% of the traffic into the green version. Try to get a handle whether this is something that behaves in an expectable and predictable way from a functional standpoint. And once we have that, we can shift the entire workload by increasing the amount of traffic that we steer into the green part of it. And you can see that it is as simple as changing a configuration file and just deploying that into the fabric. And the fabric takes care of all the rest, meaning the steering of the traffic. For those of you who actually want the breakdown, so Istio is the one that is taking care of steering the traffic between the different workloads, and Knative provides the abstractions and the resources that actually orchestrate everything behind. And Kubernetes naturally is kind of the backbone of everything in terms of scheduling the different revisions and the different pods. Now, from a developer standpoint, you can think about as actually managing your entire microservice architecture and infrastructure as code, just like you manage your Kubernetes YAMLs today, or you manage your CloudFormation elements today. But it does give you the power from an operational standpoint to actually bring in practices that are involving the blue-green deployment and actually gradually deploying into production, doing some conformance tests on the small percentage of the traffic. If you want to bring new features, for example, to some of your iPhone users and not to your Android users, you can still steer traffic with this notion just by specifying specific headers that are associated, for example, with Android phones. Now, from a security standpoint, when we think about both serverless as the fully managed infrastructure deployment mechanism versus running serverless architecture using infrastructure that we manage, there are pros and cons. So out of the box, serverless, as you all know, running inside a micro VM called Firecracker. Amazon basically open sourced that project recently at reInvent. It provides very strong isolations all the way down to the CPU level. On one hand, it's quite different than running something inside a container. But on the other hand, when you think about running it on a fully managed infrastructure, you can see here that even deploying into Kubernetes, this is something that I can actually escape from the function into the underlying infrastructure. There are multiple vulnerabilities over time in Kubernetes, and right now in Istio there is an open issue that basically enables anyone that runs the serverless function as root to actually define a user that basically escape from the mesh entirely and actually do some sniffing and east-west basically traffic inside the underlying infrastructure. This is not something that you would expect on your Amazon Lambda, but this is something that is quite possible on the new projects. This is why we basically say that Istio and Knative are awesome as a forward-looking statement from the cloud providers and the companies that are behind those. But there is a lot of legwork to actually get it into a secured infrastructure that you can trust and operate for all the use cases that are out there. So one thing to kind of keep in mind when we go into functions and serverless is how do you build this kind of perimeter around your function. So even if you're using Lambda, you can define the IAM roles, but if I, as an attacker, can manipulate an application vulnerability that I can bounce my data outside of the function or the Lambda, if it's running outside my VPC, meaning it's a fully hosted AWS Lambda, there is nothing that actually prevents me from getting the data outside the Lambda itself. Now, even though serverless offers taking off the burden of the infrastructure security, we are still, as developers and application developers, are confined to all the application security challenges that are out there. So if I have a vulnerability in my application code, or if I bring in an open source component that is misbehaving, it's my responsibility both as a developer and as the ops to actually take care of and understand what exactly is happening. Now, Lambda, in that respect, brings in many blind spots into the mix, because essentially we have very little control of how traffic is being steered from the Lambda outside. IAM should give us anything that happens if you are 100% AWS, then it should give you the ability to control what is happening east-west inside Amazon services. But if you are employing, for example, Slack or MongoDB as a service, then this is something that would become impossible to do if you're running as a fully hosted Lambda. Now, the other element that I think is extremely important when you think about security and both operations, and we talked about it a little bit on the operational side, this is the behavioral anomaly. So when you think about a microservice that is replicated as Lambda functions, how do you find an anomaly in a group that basically runs in an infrastructure that we do not control on one hand? But if something goes off this time-boxed runtime, how can I identify that something actually went off within the group? And how can I identify that something that connects to my database is not doing anything that is out of our original intent, meaning that it can interact with my database, but just as much interact with other databases or bounce data outside of my function. So searching for those anomalies is something that you need to have. It's not something that you normally find in open source projects. And it oftentimes revert to actually getting like a third-party security solution that can bring you those insights. Think about the same aspect from an operational perspective and monitoring your infrastructure. So all the open tracing and the spans that the monitoring infrastructure emit, anomalies can tell you if something goes off at a specific microservice. And the main thing that it serves is actually the ability to reduce the time from understanding that something is wrong to actually pinpoint where it went wrong and who is the person that needs to fix that element. In serverless, 100% of the times, it's going to be a developer that needs to be involved. When you think about traditional security practices, developers are not kind of the go-to persona in terms of all the security issues that are running in production. And today, once we go into serverless, is something that we do expect some level of ownership and accountability from the developers and the DevOps. And this is something that changed dramatically as we move into cloud native and as we move to an application-centric world. So just to quickly overview, and this would be kind of the last slide, of what are the application security risks when it comes to serverless. So first of all, I would say that there is nothing new under the sun in the sense that serverless, just like containers, just like VMs, it's applications, and applications have security vulnerabilities, and there's nothing that you can actually do different. There are specific elements that you want to make sure that you take care of once you go into serverless, specifically when it comes to fully managed environments. The first one is how do you deal with injection of events? So if originally we had SQL injection, now we have different interfaces like message queues and protocols that are not HTTP protocols per se, on one hand. But on the other hand, these are still vectors that I can inject input that is invalid, and I can basically bounce data and maybe get a hold of my workload. So WAFs are not kind of the mechanisms to do a full control over the entire spectrum of those vectors. And necessarily WAFs are not something that you can deploy in a serverless environment. Broken authentication and authorization at the edge is something that can expose APIs that can allow, whether it's an authenticated user that can escalate the privileges and do more than what the user was expected. It's nothing new under the sun. It's just something that you need to take care of once you propagate authentication and authorization data into the internal microservices, meaning that if my Edge API server is taking privileges actions with internal microservice, then this is something that potentially a user can exploit and perform operations that are not part of the original intent of the application. Anything that relates to insecure serverless deployments, meaning that you are not giving the minimal privileges, the IAM roles to the functions, whether it's on Knative or on Lambda. Anything that spans your software supply chain, make sure you get in open source software from trusted sources, that you scan them with relatively solid tools. I know that it's very easy to revert to open source, but open source sometimes give part of the answers to whatever is happening in your environment, anything that relates to visibility. If you have blind spots, if something goes off, it's impossible for you even to see that. Make sure you have visibility both into the ops things, the telemetry, but just as much make sure that you do that for your security infrastructure. So thanks everyone for taking the time.